Hello, welcome to another day of our probability class. Last week we looked at only probability involving coins, but today we'll be looking at other types of probability, both dice and conditional probability. How do I solve all of this with the probability tree? Probability tree is not the only way to solve it, but I think it's one of the easiest ways to solve it. So let's go in.
First of all, we draw the probability tree. Yes. So you throw a die. How many answers are possible? When you throw a die once, 6 answers are possible. It's either you get 1 or 2 or 3 or 4 or 5 or 6. So the probability of getting the first one, this is 1 out of 6. Probability of getting 1, probability of getting 2, probability of getting 3, probability of getting 4, 5, and 6. Probability of getting 2 is also 1 out of 6. Probability of getting 3, 1 out of 6. Probability of 4, 1 out of 6. Probability of 5, 1 out of 6. Probability of 6, 1 out of 6. Sorry, 1 out of 6. Okay, so what is the probability of getting a 4? It's obvious. 1 out of 6. So that is the probability of getting a 4. So let's look at conditional probability. The ones that has to do with conditional probability. So a bag, okay, this is not the conditional probability yet, but we'll look at it. A bag contains 5 red balls and 3 blue balls. What is the probability of picking a red ball? Okay, so when you pick the first time, the bag contains 2 colors of ball. So when you pick the first time, it is possible you get a blue, okay, it is possible you get a blue or a red. So let me make it more interesting and use the colors for the line. It's possible you get a blue or a red. Yes, you get a blue ball or a red ball. So what's the probability of getting a blue ball? Probability of getting a blue ball, a red ball, we have 5 red balls. And how many balls do we have in total? 5 plus 3, we have 8 balls in total. So how is it possible that you get a red ball? It is 5 out of 8. Remember the formula for probability. Number of required outcome all over total possible outcome. Okay? So what's the probability of getting blue? That should be 3 out of 8. So what is the probability of picking a red ball? It is very clear. 5 out of 8. There are 8 balls in all, and then you have 5 possibilities. It's either you pick the first red one, or the second red one, the third red one, the fourth red one, or the fifth red one. Okay, so let's look at this. A higher form of it. There are 4 blue counters and 5 yellow counters in the bag. 2 counters are taken at random from the bag. Work out the probability that both are the same color. So let's understand the question. We have 4 blue counters and 5 yellow counters. 2 counters are taken at random. Probability that they are the same color. You know you can pick blue and yellow. You can pick yellow and blue. You can pick blue and blue. So let's run the probability tree and see all of the things that are possible. So I'm going to be using black for everything to make it faster. Okay, so there are probability tree. So there are 2 possible colors, blue and yellow. So this is for blue. When you pick the first one, it's possible that you get a blue. When you pick the first one, it's possible you get a blue ball, and the second one you get a yellow ball. So what's the probability of getting a blue ball when you pick the first one? That is 4. We have 4 blue balls all over total number of balls. We have 9 balls. Probability of picking a yellow ball when you pick the first one. We have 5 yellow balls all over. Total number of balls, you have 9 balls. Then you pick the second one. Remember, it was picked 2 times. So we're picking the second one. If you pick the second one, 2 things are still possible. You can still get a blue or a yellow after you have picked blue as the first one. Then you can still get a blue or yellow after you have picked yellow as the first one. So these 2 things are still possible. Both of them are still possible. So what's the probability of getting blue as the second one? Oh, this is our blue, this is our yellow, this is our blue, this is our yellow. So how is it possible? What's the probability of getting a blue the second time after picking a blue the first time? Remember, we had 4 blues. When you pick 1 blue the first time, how many blues do we have left? We have 3 blues left. Then the total number of balls were 9. But because you have picked 1 the first time, we now have 8 balls left. Okay? Then yellow, the number of yellow balls are still complete, 5. But the total number of balls are not complete again. Why? Because we have picked 1 blue ball in the first picking. So we have 8 yellow balls. So let's do the same thing here. We picked, the first one was yellow, the second one is blue. So we've not picked any blue ball. The blue balls are still complete, but the total number of balls have reduced. The second one, the yellow balls are not complete again. The first one you picked was yellow. So we now have 4 yellow balls, and also the total number of balls have reduced. So let's go back to the question. What are the probability that both counters taken are the same color? So we want to look at the probability of getting the same color for both the first time and the second time. So this is the first picking, this is the second picking. Probability that we get the same color. So let's go. Blue, blue. So we have the same color. Blue, blue. So it is possible the first blue 4/9 times blue, blue 3/8. So it's possible that we get 2 blues. That is the first one. Or let's check. Remember, this is how you put the probability of getting blue, blue. That's what we are checking. Or probability of getting the second one is blue, yellow. They're not the same color. Yellow, blue, not the same color. Yellow, yellow, the same color. Probability of getting yellow, yellow, which is the same color. So the first yellow is 5/9, and the second yellow is 4/8. Then we multiply. 4 times 3 is equals to 12. 9 times 8, 72. 5 times 4 is 20. 9 times 8, 72. So it is either these or these. So remember, we add up all of our probabilities. Probabilities of getting the same color. Yes, the same color could be blue, blue, or yellow, yellow. Could be equal to 12 all over 72 plus 20/72. 12 plus 20 is 32. 72, denominator is the same. So take the same denominator. Don't mind myself. So our answer becomes 32/72. You can still break it down further if you want, but we're going to leave it like this. Okay, so the next one, in a cafe there are 3 slices of chocolate cake and 5 slices of vanilla sponge cake. 2 customers visit the cafe and each randomly buys 1 slice. Work out the probability that at least one of the customers had a chocolate cake. Okay, so let's do our probability tree. 2 customers bought cake. So it means 2 times. The cake was ordered 2 times. So we have the first one. Yes. And the second one. Yes. We have the first one and the second one. So it's possible that the first customer took chocolate cake. The It's possible that the first customer took chocolate cake and the second one took vanilla. And then it's also possible that in the second person took, the first one took chocolate and the other one vanilla. And it's also possible that it's chocolate vanilla. And it's also possible that it's chocolate vanilla. Okay, so what's the probability of choosing a chocolate cake? How many chocolate cake do we have? We have 3 out of the total number of cakes available, 3 out of 8. Okay, and the probability of choosing a vanilla cake is 5 out of 8. Okay, so what's the probability of choosing a chocolate cake again? That the second customer choose a chocolate cake after the first one chose a chocolate cake. Remember, the number of chocolate cakes will reduce. So we now have 2 chocolate cakes left for the person to choose from. Out of the total number will also reduce because somebody has taken one, of course. But the vanilla cake is still complete. You still have 5 vanilla cakes, but the total number of cakes has reduced because the first person has taken. Okay, 7, not 8. Let me make it neater. 7. Okay. So now what's the probability of choosing chocolate? The first person has chosen vanilla. So chocolate is still complete. You still have 3 slices of chocolate, but the total number has reduced. Vanilla has reduced. Now we have 4 slices of vanilla, and then the total number has reduced. So let's go back to the question. Work out the probability that at least one of the customers had chocolate. So that at least one of them had chocolate, both the first and the second customer, that will see chocolate at least once. So let's check the first one, chocolate, yes, there's 2. We are even asked of 1, but now we have 2. So we are going with that, chocolate, or let's check if we have other probabilities, chocolate, vanilla, yes, there's still 1 here. At least 1 means 1 and above, 1 or more than 1. So we have 3 over 8 times 5 over 7. Vanilla chocolate, yes, we still have another one. 5 over 8 times 3 over 7. Vanilla, no, there's no chocolate here. So we move. 3 times 2, 6. 7, 8 times 7, sorry, 56. 3 times 5, 15. 8 times 7, 56. 3 times 5, 15. 8 times 7, 56. So let's add up all of our probability of getting at least 1 chocolate. At least 1 chocolate. So yes, this is not how you write it. I'm just trying to make you understand it. Probability of getting at least 1 chocolate is equal to, don't mind my handwriting. Yeah. 6 out of 56 plus 15 out of 56 plus 15 out of 56. So 15 plus 15 is 30 plus 6, 36. So 36 out of 56. Remember to subscribe and like our channel. See you next time. If there's any topic you want us to solve, please drop it in the comments.